It's Wednesday, May 16th, May 13th, and today on the live stream, I'll be playing around with Spark on Cloud Dataproc. Here we go. Hello and welcome to the live stream on Adventures in the Cloud, where we explore new and interesting ideas, tools, and concepts in the cloud. My name is Yufeng Guo, and today I am delighted to be joined by Tahir Fayyaz. He's a developer advocate focusing on Dataproc. How are you doing today, Tahir?
Very well, thank you. Thanks for having me on your show.
Yeah, it's great to have you on. I'm really excited to play around with Spark and get my hands wet with Dataproc, and I understand you have quite a menu of things for us to play around with today. So I'm really excited for that.
Yeah, I've got quite a few things. Don't know how many of those things we'll get through, but yeah, looking forward to hopefully showing you some new things.
Yeah, definitely. And I see Rajan has already joined the live chat. He says hi Rajan, thanks for joining. And for everyone else on the live stream, feel free to say hello in the live chat and ask any questions you may have as we go along. So at this point, I'll switch us over to the coding view, and we've got here a little doc for us to share information, and you've added the code that we're going to be working with in this GitHub repo. So I'm going to copy that over for our viewers in case anybody wants to kind of follow along, and they can kind of see that as they go. So I guess to get us started, we should talk a little bit about Dataproc and Spark in general, so that viewers have some idea of what it is in case they're not familiar. I myself haven't done that much with Dataproc and kind of haven't really entered the Spark ecosystem, so to speak.
Yeah, sure. So Cloud Dataprocs are our managed service for running Apache Spark and Hadoop, and a few other things like Presto. So obviously Apache Spark is very popular in the big data world. So the fact that we've got a managed service for it is very useful. We have a lot of big companies that make use of the service. I think with Google, we obviously got a lot of products that have been built by Google, for things like BigQuery, obviously very popular, but we don't want to kind of not work with the open source tools that are out there as well. So not only do we have things like BigQuery and Dataflow, we also have Dataproc essentially to run all the open source data analytic tools that are popular.
Yeah, sounds good. Yeah, and that's kind of my understanding of Dataproc as well, is that it was meant to kind of serve the community and meet the developers where they are.
Exactly, yeah. So you have either people that are migrating or people that you might be a Apache Spark shop. All your engineers are using Apache Spark, so you might not want to go and learn Apache Beam, for example, and start using Dataflow when you're already using Apache Spark.
Yeah, no, definitely. And so I guess today that's what we're going to do, right? We're going to take Apache Spark, or as some spell it, Apache Spark, and run it on Hive, on Kubernetes, and we're going to do some XGBoost.
Yeah, first typo, great.
For anybody who wants to, get their first pull request on GitHub, this is a really good opportunity to do that. So as you can see, I haven't done anything in my Dataproc cluster, right? So much so that I have no clusters. I mean, I didn't even know if I was going to be greeted with like enable the Dataproc API. I don't know if there's a Dataproc API. So I'm really looking forward to kind of let's talk through how somebody would get started kind of from scratch here, right? And we should mention that Tahir, you're joining us from Europe and not and specifically London. Is that where you are?
Basically.
Yeah. So you experienced that. I guess you can kind of call it the second wave of the COVID-19 as it spread from Asia kind of to Europe before heading overseas to the US.
Yeah, been working. I can't even remember how many weeks it's been now
Yeah,
working from home. So luckily, I just managed to set up an office space in my house, and it was pretty much good timing in that sense. So
for sure.
yeah.
All right, so I guess should I click create cluster, or is there a better way for us to get started?
So yeah, so we could potentially just do everything from the UI. But one of the reasons I've created this repo is there's kind of two parts to this.
Mm-hmm.
There's creating a cluster which a data engineer might use, and that's kind of the Apache Spark and Hive component, and then also the kind of data science part as well. So it might actually be easier to do everything from the Cloud Shell
Okay,
because it will allow us to follow the tutorials and quickly use the different settings.
sweet. Let me kick open Cloud Shell, let it do its initialization. You can sometimes judge how recently someone's used Cloud Shell based on how fast it gets provisioned, right? Because if you don't use it for a
Yeah.
while, it goes to sleep, and it's like you haven't used it in a while. It's going to take a while to pull your stuff out of deep storage.
Yeah, fingers crossed. I've got it up and running now. Yeah, when it doesn't load straight away, that can be
Yeah,
frustrating.
it can be a little bit concerning. So
What would you normally like to do? Using command line, or do you prefer to normally go through the UI?
I'm happy with either one. I think with a lot of GCP things, it's useful to be aware of both.
Mm.
Especially with scripting things, it makes things a lot more reproducible. Sometimes I want to do the same thing I just did in one project in a new project. And it's like trying to remember all the menus you click through, all the options you selected can certainly be challenging. Whereas if you just have a bunch of commands, you're just like, just copy paste, set a different project
Yeah,
ID, I'm set.
yeah,
So
exactly. Yeah, I think yeah. When I first try a product, I'll go through the UI, and then the third or fourth time, I start using Cloud Shell
yeah,
exactly for the same reason.
yeah, you get tired of clicking the same buttons over and over again.
Yeah, exactly. Yeah,
But what I do
but yeah, no,
like about Cloud Shell though is that you can use it to kind of monitor things. Like after you run the commands, you can go into Cloud Shell and not Cloud Shell, sorry, the UI, the Cloud Console, and see that what you thought happened did in fact show up, which is nice. And we have some comments in the
yeah,
live stream, folks talking about Cloud Shell being preferable, and Rajan mentioned Terraform as kind of another way to help with this migration and structuring your GCP project correctly.
yeah. I've definitely seen a lot of customers using Terraform. Probably is the way to start sharing code in the future. But for now, yeah, seems to be G Cloud seems to be my go-to.
Yeah, yeah. All right, so let's. I'm gonna hop back over here. Do you think I should just clone the repo first? Would that be a better starting place so I don't have to flip back and forth, or are we happy kind of jumping back and forth in these tabs here for the time being?
Yeah, we can just jump back and forth between the tabs,
Cool.
or yeah, you could clone the repo, then you'd have the README in Cloud Shell.
Yeah. One thing I was thinking about doing was I could, as I work along, I'm gonna copy some of these things because a lot of times command instructions similar to this, right? I have to substitute values, so
Mm.
I'll have a text file open like a README like here, so that I can do the substitutions in a text editor and then copy it in properly because when you paste something in a command line and then you have to edit the text in the middle of it and you're like arrowing back and then you have to change it and you're
Yeah,
like, all right, I think that and then it's wrong. And it's like, uh-oh. And you go back and try to edit on the command line. It's always a mess. So let's
yeah,
see. Shall we choose a zone? Oh, I see. You've set the zone already. So that's perfect. So I can basically just take this and just drop it in the Cloud Shell. See, this is what I love about using these commands. So we're going to set the project, we're going to set the region, and we're going to set the compute zone. Okay, that's an interesting, because I've started to learn a little bit more about all the config options we have. And it's interesting that you set the compute zone. Like that implies to me that Dataproc itself doesn't look too closely at its own zonal configs, right? There's no like Dataproc/zone since it's
I
on
think there actually
Oh
is.
yeah.
Yeah, I think you can say also for Dataproc. I haven't done that here, but yeah, when I was testing all of this code, like there was I had some issues where things were in different zones, so I thought just to play it safe.
Yeah.
But I'm not actually sure how many of the commands actually will take that. So if you set the compute zone as a certain zone, I still had a cluster that was then created in a different zone.
So I'm running that G-Cloud services enabled to kick off all of these different APIs. We got container API, storage component, we've got compute, SQL admin. It's nice. So it sounds like we're going to be doing a little bit of SQL database setup here. And Dataproc, of course. So Dataproc does have its own API.
Exactly, yeah. So the first thing we're going to be doing is setting up Hive metastore. Mm-hmm. So that's actually where we'll be doing using Cloud SQL.
Nice.
So this first command, essentially Hive metastore is like a part of using Hive data warehouse. Mm-hmm. So it's very popular kind of in the open source community. So Hive is something that runs on top of Hadoop, so you can run SQL commands on top of Hadoop. And a part of that is having a metastore for storing all the kind of metadata about the tables that you're creating. Some people ask, when we start doing these demos of why we're using Hive when we're using Apache Spark. Uh-huh. But yeah, the reason being is that a lot of, not only Hive uses a Hive metastore, but a lot of the open source community have kind of embraced the Hive metastore and have built on top of it.
Nice. So
we can start using Hive metastore from within, from our Apache Spark code as well.
Yeah. And it's interesting to me that since Hive is just software, we have to think about the underlying virtual hardware that we need it to run on, right? In this case, SQL and cloud storage to make it all kind of woven together.
So the Hive metastore is running on top of MySQL database. You essentially need space to run it on. I'm not sure if we support Postgres out of the box, but I know the initialization action that we've created for this is using MySQL.
Cool. And so how long does it take to kind of create a cloud SQL instance in this kind of example? How long should we expect to wait around for it?
Good question, actually. So I think this should actually take 1 or 2 minutes. Okay. So it might be good to just kind of look at the Hive code while we're waiting.
Yeah, sure. Would that be, let's see, where should that be?
So that'll be just directly underneath. So apologies, this repo is kind of a work in progress. So we're building out some demos, kind of full end-to-end demos and code labs that will take you through kind of everything on top of Dataproc. So this is kind of a work in progress. So yeah.
Gotcha. Cool. So we have a question on the live chat. Sarab asks, what does activation policy equals always referring to here? What is it that's being activated?
That's a good question. That's one of these scenarios where I've taken our developer docs and just done what they've told me to do.
Nice. So. Magic command flags. Love it.
So you've got the link above where we've got a how to use Apache Hive on Cloud Dataproc, and that's been built by one of our solution architects that kind of has the full end-to-end code of how to set everything up.
Sweet.
I'm not sure if they have in there exactly why that configuration is required.
Oh, this is a nice little diagram to help kind of guide our discussion later if we need to kind of refer back to what exactly is happening. We have...
Yeah, exactly, yeah. Actually, that's a good point. We could probably quickly just go through that.
Yeah, sure.
So you've got there on the right the Hive method, the actual classical database for all the metadata. So that's essentially the Hive metastore.
Okay.
Or where the metastore is stored, and you'll have the actual metastore service living on a Dataproc cluster. For that to connect to the Cloud SQL database, it needs to use a Cloud SQL proxy. So that will be set up for you. And then there's also the Hive server. So there's the 3 components that will be on the Dataproc cluster.
Okay.
And then when we actually create a table, so imagine we were creating a table to be stored in the Hive data warehouse. On a typical cluster, the storage would be HDFS. Because we're doing this in the cloud, we're going to use Google Cloud Storage as a kind of drop-in replacement for HDFS.
Nice.
So the actual data is in cloud storage.
Yeah, HDFS is something I've heard of or heard about over the years. I don't know that I necessarily realized that GCS or Google Cloud Storage is the equivalent. I didn't realize. I thought it was this like fancy thing that you could only get when you're running Hive or running Spark or Pig or something like
that. Yeah, so I think GCS is kind of like it's a platform, right, that will cover a lot of different use cases, and we've essentially made it work as a drop-in replacement for HDFS, which is nice.
Yeah, totally. And Saurabh asks a follow-up question about the cluster in this diagram, whether it can be ephemeral, if the whole cluster can be ephemeral rather than, I guess, different pieces of the cluster.
Yeah, so the Hive there's essentially different setup. So if you're you probably want to have the Hive metastore servers consistent, always running. So you could have it as an ephemeral cluster, but I think I'm not too sure why we've got this ephemeral cluster there. You would ideally want that running all the time, because you would be used by different services that will want to connect to that. So
yeah,
you probably have a long running cluster.
Gotcha. So let's check back in on our SQL. Looks like it's finished, and we've got a primary IP address all lined up. It's nice.
Yeah. So from that, then we can actually set up the Dataproc cluster. You'll notice with the code, there's a section that says initialization action. Are you familiar with that?
No, I'm not. I think I may have set up Dataproc once before, ever. Like when I first started looking at GCP stuff. So yeah, should we dig into what is living in this file? Also, this looks like it's specific to a region, like there are buckets for every region.
Yeah, so wow. I'm not sure the exact reason we've got a region there, but the initialization actions, we have them hosted in a GitHub repo. Actually, if you're doing this in production, the recommendation is to clone that file, the initialization that you'll be using, and actually have that on your own GCS bucket,
right?
Instead of just using our GCS bucket. For demo purposes, we're just going to use that hosted version.
Okay.
But yeah, we seem to have a file for. I think it might be because of the cross-region issues. So yeah.
This is what I'm doing all the command line controls. All right, so I wanted to copy that script down. It says the bucket does not exist. That's great.
Yeah. So you got the dash before the one.
Oh, is there no dash?
Yeah, it'll be US Central.
Yeah. Editing on the command line. Awesome. So now let's pop that open and see what we're working with. This is quite a long file. Woo.
Yeah. So the initialization actions do quite a lot of things.
Yeah.
I probably don't have time to go into it, but
holy crap.
Yeah, one thing to notice is that when we do the actual, when we actually run the gcloud command, you'll see that we'll have some metadata. So that metadata is then used in the initialization action. So that's how you could potentially have one initialization action that could potentially do different things, or if it needs a argument, that then it will take that from the metadata.
Interesting. And then there's property too, which seems to be a similar type of thing going on. It's interesting that this is GS with its project. Did we create this bucket automatically at some point?
So yeah, actually we needed to do that. That is would have been in that link. So if we go to that, have you already tried to create the cluster?
I already ran the command, and we have this error. And it has multiple errors. Failed to initialize cluster. Bucket not found. Bucket not found. Bucket not found. Interestingly, it
Yeah.
didn't have it's
Okay.
not saying that the project name. I must not have saved the project ID. Oops.
Yeah. So actually, if we maybe follow the link, it has all of the steps in there. I tried to kind of copy as many of the steps as possible into this repo, but I must have missed that one.
Gotcha.
Okay.
So we got this. We got this reference architecture that we talked about. Considerations for multiple region architectures. We're gonna gloss over that. Create the warehouse bucket. So this guy right here. So we need to set our project, and I think we can get away with just running it directly. Save that for us. And we'll run these two commands. So it's, yep, created that warehouse. And now, well, I'm not gonna prematurely run that command again. Let's just see. It looks like, yep, then it has us do the SQL cluster, and then it has us run this thing. Okay, so hopefully this will now work. Let's pop back over here and take a glance at some of the things that it talks about. The Hive warehouse bucket, interesting, is in the Hive metastore warehouse dir property. And that's our GS util, right? That's this one right here.
Yeah. So the actual properties will get applied. So that's a property for the cluster, whereas the metadata is used by initialization action.
Okay. Yep. And it starts talking about the initialization action there. And so hopefully we've got. Oh, it's still complaining. Oh. So this is an interesting thing, right? It got the error, but it still created the cluster?
Yeah. So yeah, that is one of the frustrating things. Sometimes the job will fail,
Yeah.
and then you think, okay, I'll create a cluster again, but you actually need to delete it. So you should hopefully delete quite quickly.
All right, so I'm gonna try to delete this.
Yeah.
Right, I'll go for it. Nuke it. Obliterate the cluster from existence. And then we have to hope that the Dataproc service kind of tables around the names get clear fast enough for us to put it in without it thinking that it still exists, even though it's gone, quote unquote.
Yeah, I think it updated pretty quickly. So
All right.
yeah. It's probably a spanner in the background somewhere they're doing this magic.
All right, so while this is deleting and we're waiting to have the chance to run the next one, should we look ahead to the next step?
Yeah, so what we'll actually do is we'll create a kind of test table.
Okay.
So I think for now, for the Hive thing, let's just follow the documentation. So I might not have put all of the steps there.
Sure. It says we need to copy the sample data set to our warehouse bucket. Sounds like something we can do while we wait for the cluster to get up and running.
Yeah, exactly, yeah.
Great. Oh wait, wrong terminal.
Yeah, see, it does take a while to delete the cluster.
Yeah, it's taking its time. We got a question from Rajan saying, is there a plan to embed metastore within Dataproc itself as part of the cluster starting, i.e. via an option or flag to reduce the toil? Love the terminology. Yes, we definitely want to reduce that toil. That's what we should rename this. This is Cloud Toil Live.
Yeah, so the plan to embed metastore within Dataproc itself as part of the start. Oh, I see. Okay, yeah. So as in have like a check button as opposed to doing the initialization action.
Because it's so boilerplate, you know, like it's just like do these steps every single time, everybody.
Yeah, it's a good question because we do have that for other products. So for example, if you want to use Jupyter, which we're going to use later, we have these things that are called optional components. So that's where it's more like a tick box. When you create a cluster, you'll say tick box include Jupyter, include Zeppelin, include a few other things. So it's definitely something being requested. I don't know exactly when or how that could be implemented, but yeah, you can imagine anything that's an initialization action. The long-term plan probably, if it's requested enough by customers, it would be to make it like a tick box option when you're creating a cluster.
So if this is taking a while to delete, how bad of an idea do you think it is for me to just give it a different name? Oh, it finished. Okay. Because like I've tried doing that before, right? And like instead of Hive Cluster, it's like Hive Cluster 1. And then later there's something hard coded in some script and it just fails terribly. And it's always a very, it's a dice roll.
Yeah, I do that quite a lot. I get frustrated and then I end up having 1, 2, 3, and then I need to change all the other code. So yeah.
That's real. So we're running that now.
Yeah.
We copied our thing. The sample data set is compressed in the Parquet format, often mispronounced as Parquet format, and contains thousands of fictitious bank transaction records. And we got date, amount, and transaction type. Cool. Now they want us to create this external table, right? This Hive table for the data set. We're gonna Dataproc job submit Hive. So G-Cloud commands are often very semantically understandable. Here, what is the significance of having Hive here as opposed to just Dataproc job submit? Are there other kinds of jobs that you can submit to Dataproc as well?
Yeah, no, actually, so when you go to submit a job, you have to define what type of job you're submitting. So that'll be Hadoop, Spark, PySpark. So Spark will be Scala or Java. PySpark will be Python. You have Spark R, have Hive and Presto.
Nice. So that's a lot of choices, actually. It's cool.
Yeah. So yeah, you can run that as a command, and that will hopefully show us, how easy it is to create a table. So one thing difference here and what we're going to do later on is here we're actually using Hive to create a Hive table.
Yeah.
So as I mentioned before, Hive supports its own metastore, but and then further on we'll kind of show how we're going to use Spark to kind of interact with Hive.
Gotcha. We got an interesting comment from Tibor. He says, at creating the Hive cluster, my attempt has failed as I've exceeded my quota for CPU and storage. So following along on the stream. Sorry to hear that, Tibor. I'm wondering what kind of quota he might be working with. Because the defaults that we're passing in with these commands, hopefully they're not terribly huge, right? It looks like there's only 2 worker nodes.
Yeah, so you should have just you needed 3. Well, yeah, you need a total of 12 cores, so it'll be.
Okay, so it's a little bit.
Yeah. But normally you could request, if you request CPU quota, you normally get that straight away. I'm not sure on what type of, if that's on a personal account or business account, but Tibor, if you can maybe try and increase your quota, it might be increased quite quickly.
Yeah, I see here the VM instances. You're saying there's 12 cores distributed across these 4 machines.
Exactly, yeah. So we've got 4 CPUs on each machine.
And it looks like our Hive table was created. That was an interesting command. I was kind of looking at it while you were talking earlier. Creating this external table called transactions with 3 columns: submission date, transaction amount, and transaction type, stored as Parquet. And the location is that Google Cloud Storage bucket that we created earlier. It's like shockingly readable,
Exactly, yeah. I think a lot of people think, this is going to be really complicated. And you look at the code, you're like, that's pretty simple. So yeah, you're essentially creating you've got this default database which is living at this kind of data sets repo, but when we go forward, we're going to create our own database, and that's essentially just another folder or directory within that GCS bucket.
Yeah, so it's not like on the MySQL database.
Exactly. So the MySQL database is actually just storing the metadata. So that's a good question. So if we go back to the GitHub repo, you can run this command, and what that will do is, did you run the command to create the table?
So that was this one right here.
Yeah. Okay. Yeah. So then if you run,
so we're going to do the select.
So yes, if you run that next command, yeah. So we're just selecting 10 transactions from that table. And you should be able to see the output here.
And that's just because we copied that file into that place earlier. We copied whatchamacallit, I'm gonna make this bigger. Like we ran that cp command here. We copied a Parquet file into this folder, and so it's like we almost just dropped a database, so to speak, into existence. And then defined, basically said like, oh, by the way, this exists.
Exactly, yeah. And that's where the metastore service comes in, right? So now if another user came and said, show me what tables are available, it will know that that file exists there. So if you're using Google Cloud Storage, you can just store Parquet files or any like CSV files in GCS, but then you have no way of kind of, there's no easy way to kind of share what data is essentially in your data warehouse.
Totally. It looks like in moving the cloud storage or the Cloud Shell environment to a new tab, it dropped all my command line args. Another reason to set all of your things via the command line. All right, so now all that is set. Again, we've kind of reinitialized our environment. We can copy this command, run it here, and we can get a nice list. This is nice though, in terms of like we were able to get something running and things just like go. And here's our little transaction list. We got the 10 things, and it gives all this metadata about the job too. So we got the 10 rows right up here, and there's a number of different kind of values talking about job kind of timing and such. It's cool.
Exactly. Yeah. It's pretty useful. Like debugging. You can actually SSH into the master cluster as well and start running things from there.
Yeah.
I prefer to actually do everything from the gcloud command, because then you have a record as well of the job actually being run. So you can go in Dataproc, whereas if you SSH into the machine, you won't have that record of the job being run in the Dataproc UI.
Yeah, so it kind of gives us an audit log almost.
Exactly, yeah, and you can see like why the job failed, etc. So yeah.
Yeah, and it looks like we're deviating from this guide at this point. We'll go back to the GitHub repo.
Yeah, so that guide was more to kind of get set up.
Yeah.
What we want to do now is create our own database, so we can run that command to create a database.
Yep. And so this, I noticed it, big difference between this command and what we were doing just a little while ago, is that we are not pointing it to any sort of existing Parquet file. Right.
Exactly, yeah. So now what we're going to do, so first we're creating a database, and then we're going to look at the Spark code, and the Spark code is going to create the table for us.
Oh, cool. Okay. So that brings us kind of to this. Oh, and we should confirm that it worked. So will we only see the one, or will we see both the transactions and the mortgage?
You'll see so the transactions is actually a table. So that was a table within the default database, and now we've created a new database.
So the default one and the new one we just made.
Exactly, yeah.
Awesome. So I see here are databases. Nice. Making things.
So what we can probably do, like kind of thinking about the time, what we can probably do is, so what I wanted to do here was actually create a cluster and a Dataproc cluster on Google Kubernetes Engine.
Yeah.
So not only can you run Dataproc, spin up a Dataproc cluster that's now running on, as mentioned in the comments, like 3 VMs as a minimum. You could actually just reuse another GKE cluster.
Yeah.
Google Kubernetes Engine cluster. Anyone's not familiar with the acronym, and you can still use, and that will allow you to run Spark jobs on Kubernetes.
Nice.
So Spark and Kubernetes is something that we open sourced. We created, I think it's called an operator for Kubernetes.
Okay.
And we kind of have built that as a managed service. So yeah, that's a good question actually in the comments. What's the advantage of Dataproc on GKE versus Yarn? I think that's kind of immediately the first question we get. I think the kind of reason I've seen it being used, or like why people are interested in it, is things like being able to kind of manage your resources better. So obviously Yarn was developed for Hadoop, so it has a lot of legacy around that as well. If you wanted, for example, a more lightweight way of running Spark on a cluster that you're using for other applications, then instead of having a whole Yarn cluster running, you could just make use of your existing GKE cluster, Kubernetes cluster, and run your Spark job from there. So it's just kind of another way of running Spark. And I think there are certain improvements that have been some kind of performance improvements that have been made. I'm not kind of too familiar. It's something I'm learning more about as well. But yeah.
Awesome. Yeah, I mean, I think especially for those of us who might have a GKE cluster already running, it's like instead of provisioning new machines dedicated to Dataproc, you can just kind of have it all in one blob of compute, which is potentially attractive from like a management standpoint.
Yeah, exactly. Yeah. And a follow-up question was, can you just run existing Spark code? So remove code from what's running on Yarn and run that GKE cluster. So this example we're doing is that the Spark code changes, stays exactly the same. Nothing changes.
Wow. Nothing.
So you can repeat that.
Oh, they're saying like that's amazing that like nothing changes at all. Like there's not even a single change in the Spark code. It's all outside of that code base.
Exactly. Yeah. So the Spark code stays exactly the same. It's just the runner essentially that's changing, or the executor. And in fact, you can run the same gcloud command as well. So you would be running gcloud Dataproc submit PySpark job, and you'll just be using a Dataproc cluster, and that will be running on GKE. So even the gcloud commands stay the same.
Awesome. Yeah, I mean that's crazy. Like it's purely kind of in the back end, so to speak, and abstracted away to some degree from like the direct interface.
Exactly. Yeah.
So how do you want to go forward here? Do you want to go through this, or do you want to skip ahead to the next chunk?
Yeah, so it might take a bit of time to set all of that up. So what we could maybe do is we essentially want to create a bucket. We want to create pull in some mortgage data that we can then use from a Jupyter notebook.
Yeah.
So just having a look at what part we can kind of skip to. So bear with me a second. So yeah, so if you go to 1.3, I've said to create a new bucket, but we could actually just use the same bucket.
Sure.
So you could just copy, where I've said copy data to the GCS bucket.
Yeah.
You could just copy that to the same bucket instead.
And I'll just set this GCS bucket value to be the one that we were using, which I believe was this one. And then we can directly use the commands as written. That all look okay to you so far?
Yeah, that looks good. Copying, ls, here we go, eval and train. Perfect. So yeah, so this is some data that's been made available by the NVIDIA team, and we're going to be using their code in another cluster. So yeah, so at this point, you might want to clone the repo so that you have
Yeah.
the code to create the table.
Should I clone it to the Cloud Shell or in my actual local disk?
I think to the Cloud Shell will be fine. Yeah, if you're running it from there, yeah, because you shouldn't have to modify any of the code. But we can have a quick look at the code.
That's another funny typo. It says clone twice. It says git clone clone.
Okay,
Yeah, I was like, why is that? Complaining. It looks like it's not. This folder doesn't exist. We're
okay, yes, you'd have to. So yeah, you'd have to cd into Cloud Dataproc first, and then yeah.
Nice. So that's a small edit there. All right, let's see. So we got a bunch of things here. Let's show the folks. Oh, okay. Yeah, this is just our repo, our GitHub repo.
Yeah, so the code we want to look at here is that's the bottom file there, the Spark CSV Hive Parquet file. Yeah, perfect. Yeah, you can open the editor.
Yeah, I figured may as well make it easier for folks to follow along visually, so I don't have to jump between Vim and the command line. Where are we at? Spark, Hive, GPE, and this file. Wonderful. And that means we can render the notebooks if we want to as well.
Oh, cool. I didn't know you could render them.
I think so. It looks like it recognizes it. Just kidding.
Yeah, it has a logo there. But
yeah, it recognizes the extension and recognizes that it's JSON.
So what we're doing here is, so the actual code is we're creating a Spark session, and then on where, yeah, so what we're setting where the CSV files are. So these are the CSV files that you just copied over, and we want to load them into a Spark data frame. And if this was a part of your processing pipeline, this is where you would use Spark to kind of process the data and manipulate the data in whichever way you want. But for the sake of this example, we're not actually changing any of the data.
Okay.
But what we are doing is we're loading that data in the Spark data frame, and then we're saving that data frame as a Hive table in the Parquet format.
Oh, okay. So we are doing something. We're transferring the data into Parquet.
Exactly. Yeah. So this is where it would be, the difference would be if you had the data already available, like already in the format that you need, you could just take that and save it as a Parquet table using Hive, which is what we did before.
Yeah.
But if you just want to kind of process the data, manipulate the data, join with other data, then that's kind of the use case where Spark would be powerful.
Right. Even if it's like a trivial change where it's like I need to drop a column or like merge two columns, like little things like that, or just like make sure there's no leading zeros, or like clean up a type and round it to an integer instead of keeping it a float. Like there's so many things that I feel like little things that people want to do that the data is just not quite the way you want it to be. Even if it's like changing the order of the columns, you could very trivially make that happen in the context of this file.
Exactly, yeah. I think I used to kind of be the person that would be like, oh, it's just one little thing, so I'll just change it. We're using SQL, and then you end up changing another thing, and then another thing, and then you've got this horrible SQL query that you're trying to run to manipulate the data, and you're like, I should have just done this in something like Spark or in the first place.
Yeah.
So yeah.
It's the like months later, it's that meme. I've made a terrible mistake.
Exactly. Yeah. And what you'll notice that when we're creating the Spark session, where we can put some configuration settings there. So we're pointing to the service endpoint. So where we created that Hive cluster before, we can see we're pointing to the master cluster. So that service becomes available so if you were to run this code on another Dataproc cluster, you could point to the same to a service that lives in a different Dataproc cluster. So And in the warehouse location, we're telling Spark where the warehouse is.
Yeah. And to be clear, like you're talking about this, right, for like the service cluster, and the reason, the significance of this part of the string is that it matches this right here.
Exactly, yeah.
Yeah, just so viewers know exactly what we're talking about when we say like you'd have to change something, and they're like, what do I need to change?
And then the warehouse location should match where we created that before.
Yep.
So, and then you can see we've got enable Hive support, so that will essentially tell Spark to use Hive to kind of enable the integration between Spark and Hive. Not all features are available in Spark when you do that, but yeah. What that means is that you can start saving the table. You can save the table as a Hive table now from within Spark.
Nice. So I guess we should try to run this somehow. It looks like this is kind of the setup for it. We had our arguments and stuff somehow.
Exactly, yeah.
So here are 2 arguments. Oh, I see what you did there with the extra dash space.
Yeah, so you would have the dash to kind of do
to our version.
That will go to the file.
Okay.
So what we'd probably want to change here is instead of pointing to the Dataproc on GKE cluster, you would just want to point that to your...
Oh yes, that's right. There's that for sure. So this is the data set. Oh, and that looks fine.
Yeah, it's the one before that where we've got rapids.
Yes.
You probably want to change rapids to warehouse.
Yeah, and didn't we put it in another subdirectory or something, or did we not?
Yeah, so we used the same
bucket. Yeah.
But we used the mortgage small directory.
Yeah, so we'll add that. Oh, you already have that. Nice.
Yeah, so
we got it covered. And then, as you mentioned, we need to change this value. Do we just leave it out, or where would we pass the cluster name?
We already need a Hive cluster, yeah. So we could just write Hive cluster there.
Right, because this is the name of our cluster.
Exactly, yeah.
So I'll just put that here. It's kind of misleading, though. Comment that out. Whoa, it's HTML. That's funny. I'll just do that. Be normal. All right, project and region are already set in that environment, so I think we're good to just run this.
Hopefully that should work.
Yeah, let's see what kind of errors we get. We're already in the right folder, so it points to the file right here, right? And that's a relative path. And since we're in the directory already, it should go. Doop 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 doo. No immediate complaints. That's always a good sign.
Moment of truth.
Yeah.
So I had some issues earlier where it wasn't connecting to the Hive metastore because I believe it was because it was in a different zone. But yeah, I'll make sure that when we kind of in this repo we have everything working, and if it does need to be in the same zone or there's any kind of network settings you need to have, we have that properly listed.
Yeah, and when it talks about creating HDFS directories, right? We talked about how HDFS on GCP is just cloud storage buckets. Here it really looks like it's on a local disk of some kind, right? We see it's root/tmp. It looks like it finished.
Yeah.
Aha.
Nice. So that should have created. Yeah. So the HDFS thing, there's still kind of temporary files that created. So HDFS is still essentially used for various different things when a job's running.
Mm-hmm. Is that when it talks about storing files to these folders, do these folders, even though they're temporary, are they on cloud storage or are they on the Hive cluster, aka the GCE instances, those virtual machines?
Yeah, so they'll be on the actual GCE instances.
Oh, okay.
Yeah.
Gotcha. All right, so this finished. What are we expecting to? I guess I should look at the next step.
Yeah. We can check that that's been created correctly. Yeah, we can go show tables. So you see that command there?
Oh, this one here.
Yeah. But we'll actually want to change that again to use
Uh-huh.
the Hive Cluster.
Yep.
Actually, no, that's already there. All we want to do is change that to say show tables in mortgage, because we want to see it in the mortgage database.
Just like that.
Yeah.
Dataproc cluster. Probably should just echo out export the environment variable name, but so far this episode has been filled with me not setting commands correctly, so may as well continue that trend. What did I do wrong? Must have file. Oh, it must. It's a new line problem.
Okay.
So yeah, I can either add slashes or just do it this way. So we're expecting to see the tables in the mortgage database. Oh, those two. Nice. So we see the tables are there, and we could probably do some kind of list or something. Maybe you already have that. Is that what's next?
Yeah. So the next step was to actually, I can see my formatting's all broken.
Yeah, it's all good.
Let's see. What we actually wanted to do, I don't know in terms of time, if we have enough time to set everything else up. But what we wanted to do was actually create a new cluster that had GPUs on it.
Wow.
And we were going to use the Rapids initialization actions. The Rapids is something that's been created by NVIDIA. So they have a lot of integration. So when you use that Rapids initialization action, it will set things up like XGBoost for you. So the Spark and XGBoost library, and along with the GPU initialization action, it means we can have a cluster running that's got GPUs enabled, and we can use things like XGBoost integrated with those GPUs, all from kind of one notebook. So you can imagine we could probably open the notebook in the GitHub repo and go through the notebook from in Git.
Let's talk a little bit about that. The Spark CSV. No, that's the one we just looked at. Is it XGBoost GPU? Is that the one, or did I go to the wrong one?
You can, if we look at the first one quickly, so the Hive one first.
Sure.
So what we've done in this notebook is we've shown how the data engineer would have created the Hive tables for you, and then from another cluster you can now use those Hive tables. So
oh, cool.
Very simple. You kind of connect to the Hive service.
Yep. And
then we can start using Spark to kind of analyze that data. So exactly what you ran before in the command line. I put this in the notebook. We can start looking at the data.
And we can run a describe, gives us our schema, load it into a Spark data frame with all of our different columns. And we can do all of our different kind of analysis, some example analysis.
Exactly, yeah. So I just got a few examples here, and you can use SQL or you can use the data frame API.
Right.
So this is really cool at the end where you can actually go from a Spark data frame to a Pandas data frame.
Nice.
So we've got this arrow enabled setting. So it uses arrow to do that conversion.
Oh, okay. Yeah, I was wondering about that.
And then what that means is that you can start then using kind of any kind of Python libraries on top of that code. So
exactly.
This is useful in scenarios where you want to plot the data. So to plot the data, you'd convert it to Pandas data frame, and then you can use the various plotting libraries to analyze the data.
That's awesome. I mean, just even beyond plotting, getting it into Pandas just opens up the door to the entire world of all those other Python libraries and tools that people use to analyze data. So that's a really nice convenience function there.
Exactly, yeah. I mean, you also have Pandas UDFs built into Spark as well. So if you wanted to, you essentially kind of do batch processing of, not batch, sorry. If you want to parallelize kind of workloads onto a Pandas data frame, you could use a Pandas UDF within Apache Spark.
Nice. So that can just do stuff in place, basically.
Yeah, so you can imagine if you want to do things in parallel, and because of the nature of Apache Spark, you can then do things with those Panda UDFs. I've probably done a very bad description, but it's definitely worth looking at if you're looking to kind of manipulate data using Python from within Spark. Then have a look at Pandas UDF.
Yeah, and not having to convert back and forth between kind of Pandas and Spark is also like a nice savings from a computational standpoint if you're doing larger jobs.
Exactly, yeah.
Cool. So should we look at the other one?
Yeah, exactly, yeah. So we can go to the next notebook. So yeah, once you've done your kind of exploratory data analysis, this is where we're now making use of to build a model. So what we're doing here is when you would have created the cluster, you would have enabled GPUs, and then within the Rapids library, they've got this GPU data reader. So you can see that there, yeah. So what that does is actually uses, instead of using Spark and the built-in reader for Spark, it's using a custom GPU reader for reading the data in.
Nice.
So and that just improves performance.
Yeah.
So you can imagine people load the data a lot faster.
And so does that mean it's reading it into the GPU memory instead of the system memory?
Yeah, exactly.
Is that the idea?
Because then that's used later on for the model.
Great. So here's all our features. I'll scroll past that long list. And we have our data that we're reading in.
Yeah. So one thing here why I kind of showed this is that you can't read the way that we use Spark to read from a Hive table before. You can't do that with a GPU reader. So what we can, so when we created our tables from Hive tables, and we saved them as Parquet format. There's essentially Parquet files in GCS, so we can just read those files directly.
Nice. Okay, so the GPU data reader I see here has a .parquet, and you can pass it a Parquet URL, and it'll read it in that way. Yeah.
Exactly. Yeah.
So it sounds like you're saying the GPU readers are not compatible with the CSV. Is that the idea?
No, so they are compatible with CSVs, so we could have just read the CSV files directly.
Oh, okay.
So yeah, but yeah, Parquet is kind of a very popular format for storing data. So yeah.
So here we'll do the same thing with eval. We'll create our classifier with just a few parameters, and then we have a benchmarking function to do our timing. Nice. With benchmark, I like it. It's clean.
Yeah. So this code is taken from the Rapid repository. So I have to give credit, obviously, to all the work that they're doing. So we're working with them to kind of build out some demos.
Oh, nice.
And they've got a lot of really good content already. So what I'm trying to do is take that content and kind of test it, how it works in GCP, try and contribute back to Rapids as well. So, yeah.
Very cool. I mean, like, what's neat about this is when I look at this, it's very in line with the workflow. Like when I look at these steps, the code, like, yes, the code's different, but the kind of stepping and the phases of the transformations, training the model, save the model, load the model, like these are all pretty standardized steps across whatever library someone might be using, across whatever environment they might be using. And so it's really exciting to see this kind of merging and I don't know, harmonization, so to speak, of all the different frameworks and libraries out there to kind of be in the same headspace, if you will, around these workflows.
Exactly, yeah. And I think that's a good point. And the question from Rajan, like, kind of is a good kind of follow up to that, or like a integrated question.
Oh, that's a good question. Do you mind reading it out loud?
Yeah, sure. Yeah. So it says if you took the same code and ran it on a platform, We're saying,
Hardware?
I'm not sure. Was
I'm
HW
guessing it's
sample size?
hardware.
Okay, same hardware as Dataproc. Would you expect to see any differences in performance? Um, it's a very good question. I'm not sure how the GPU read etc. works on AI platform notebooks. Yeah, I'm not sure if that's available.
Yeah.
If it is, then I presume that part will be the same.
I think it would be really
Um,
interesting, especially because I know with the AI platform notebooks specifically, it allows you to install rapids, right? So there's a rapids, instance that you can load up, but it's just one machine. So it's like, how do you compare the two in those situations? What was the architecture of the one that you were planning on doing with GPUs here? Like, how many GPUs? How many machines? What kind of GPUs?
Yeah, so we created a cluster. So the demo that's been created had two worker nodes, so two high-end
Mm-hmm.
worker nodes with 32 cores each, and four GPUs in total.
Across the three
Um,
machines? Were you going to attach two GPUs per worker? Was that the plan?
yeah, so
Wow.
two each worker. Yeah, so
That's
the master node isn't used
right.
in this scenario.
Yeah. But like if you imagine we could do something like, what is that? If we had an 8 core machine with four GPUs attached to that single machine, yeah, it would be like sort of comparable, right? Like, but I don't know that I mean, we'd see some differences because we can't mimic the exact same hardware. But at the end of the day,
Mm.
it's all running just on compute engine. The only difference is one has the overhead of, well, they both have Spark installed and Rapids installed. So I don't know that there really would be that much of a difference in my mind, at least. It'd be a cool
Yeah,
experiment.
yeah, and I think that's where we want to get to. We're starting to look at how does Dataproc and AI platform kind of integrate better? Um, we definitely want to, yeah, have a kind of cleaner integration between the two. And I think that's going to be a common question going forward is like, what should I use? Should I just spin this up on AI platform or why do I need Spark? And I think it kind of goes back to the beginning of like, why should I use Spark if I'm using BigQuery? I think it's not like there isn't a one is better than the other. It's about like yeah, finding the workflow that works for you
Yeah.
and your company.
Yeah, it's just like how there's lots of different kinds of like saws and drills and things like that to build stuff, but it's not like there's one that is the best for everything. So you kind of have to choose the tools that fit your use case.
Exactly, yeah. And yeah, I think I'm keen as well to kind of experiment. I don't know exactly the differences. Like, I don't know how distributed training works on AI platform.
Sure.
So yeah.
Yeah, and Rajan has a few last follow-up questions here. He's talking about kind of cross VM chatter as opposed to a single VM, right? I could see there could be kind of the overhead of having two VMs versus one single consolidated pool of resources. But then at the same
Mm.
time, the distributed workloads, not having them, I don't know. I can't say really definitively without testing. Um, and then asking
Yeah.
if we can run notebooks in BigQuery. I I want to say you can run notebooks with BigQuery queries.
Yeah, I
But,
think things all the way around, right? You can use BigQuery from within Notebook.
yeah.
Uh, so you can actually you can use all the BigQuery libraries are um, available in notebooks on Dataproc as well. So I find myself doing some things in BigQuery because you can connect to BigQuery Storage API. You can pull that data into Spark, do some work in Spark, and then yeah.
Yeah.
So I think all the products really speak to each other quite well now.
Yeah. I mean, I think, that pretty much wraps us up for today. Thank you everybody for joining to hear, as always, a pleasure. And I think we're going to have you back on to do the second half of this, right? We have so much left to do. We got to make our GKE cluster. We got to put on GPUs. We got to run all this code uh, and run some
Yeah.
benchmarks. So thank you everybody for joining. It was a lot of fun. And we'll be back on Friday. We'll be doing the second part of our experimentation with AI platform pipelines, messing around with Kubeflow and TFX. If you have any thoughts on which one you'd rather see, I think we're going to see both. I'm going to try to fit it into the hour as we've kind of begun to learn an hour is a shockingly short amount of time to like do anything real, right? So you can only do so much. And yeah, with that, be well, hope be safe, and we'll catch you on Friday. Thank you again, Tahir, for joining us. And
thank you for having me. It's been great.
We'll see you next time.